In this video, we're going to look at solving exponential equations. So we're going to be looking at equations that have variables in the exponent. Let's start with a simple example here, and I'll talk about this rule I've got written down. 5 to the x equals 25. This is an exponential equation because the variable is in the exponent. Now you guys at this point should know how to solve certain types of equations. You should know how to solve what we call linear equations, which would be something like 3x plus 2 equals 4x minus 1, where you get the x's on one side and the numbers on the other, and you solve for x that way. Then you should know how to solve quadratic equations. Those have squareds in them, like if you had x squared minus 5x plus 6 equals 0. You could factor that. You get x minus 2, x minus 3 equals 0, so x equals 2, x equals 3. Did I do that right? Yep, okay. Or if it was something that you couldn't factor, say like x squared minus 7x plus 3 equals 0, that's not going to factor, then you'd have to use the quadratic formula. You're building on your knowledge of types of equations. We've got linear equations that we started with when we were first starting algebra. Get the x's on one side, get the numbers on the other. Then we graduated up to quadratic equations where we had to get everything on one side. Oops, looks like I did an empty set there, but we get everything on one side, get 0 on the other side, check and see if it factors. If it doesn't factor, we learn the quadratic formula. Next type of equation we're going to look at most likely is an exponential equation. Now there's other equations that don't start off looking like this, but after you mess with them a little bit, they do end up either being a linear equation or a quadratic equation, like rational equations, which would be equations that start off with fractions, but they are actually linear or quadratic equations. So let's get rid of this, just to kind of give you a little background. This is a different type of equation. You have to have a different strategy for solving it, and that's where this rule comes in. This rule says if something to the x power equals that same exact number to the y power, then x equals y. This a value here, that's your base. In order to use this property, you have to have the same base on both sides. You have to have something to a power and that exact same number to a power on the other side. Let's look at our equation. 5 to the x equals 25. As I've been babbling on about types of equations, you probably have already figured out the answer to this equation, which is great. 5 to what power is 25? It's 2. 5 to the second power is 25. Obviously, we're going to be doing equations that you can't just do in your head like that, and so we need to have a strategy. So I thought we'd start with this easy equation so you could see how the strategy works. I want to make this equation in this form, so I have to have the same base. I have a base of 5 on the left-hand side, so I need a base of 5 on the right-hand side. So I have to change 25 into 5 to some power, so it keeps its equal value. Well, that would be squared. I can't change the value over here. I just change how 25 looks. Now, 5 to the x equals 5 to the second power fits this form. Therefore, x equals y. Therefore, the exponents equal each other. So I can just drop down my next step and go x equals 2 and set the two exponents equal to each other once you have the bases the same. That's the strategy. Now, not every exponential equation is going to be able to be solved this way. You're going to have to use something called logarithms to solve ones where you can't get the base to be the same. For example, if I said 5 to the x equals 7, you don't have a way to make 7 5 to some power. There's no nice number. The way to solve this is to use logarithms, and you'll be getting to that shortly, I'm sure. We'll cross that bridge when we come to it, but just be aware this property you're going to be using when you can get the same base on both sides. So you kind of got to be good at, well, let's not get rid of that. You kind of got to be good at your knowing, say, your powers of 5 in this case. 5, 25, 125. Your powers of 2. Let's just jot those down real quick. Powers of 2. 2 to the first is 2. 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16, 32, 64. Those are your powers of 2. They're like in a family. Your 3. 3 to the first power, 3 to the second power, 3 to the third power, 3 to the fourth power. It's good to recognize those, especially those. 4 to the first, 4 to the second, 4 to the third. 64, I think, right? Okay? It's good to recognize, though, at least those numbers and how they are in the same sort of power family, okay? Let's look at our first example that's a little more complicated. How about we do 16 to the 3x equals 8 to the 3x plus 1. Now notice our bases here. We've got a 16 and we've got an 8. What we want to try to do is turn these bases into the same thing. So if we look over here in our little power families here, 8 and 16 are both powers of 2. I have a 16 in my 4 family here, but I don't have an 8. So 2, this top number up here, 2 is going to be the base that we want to use. 16 is 2 to what power? 16 is 2 to the 4th power. So I'm going to change that 16 to 2 to the 4th, and then it keeps the 3x up there. 8 is 2 to the 3rd power, and I'm going to keep that and then keep the 3x plus 1. This is the big step right here to recognize what base you can use on both of these numbers. So I got a 16 and an 8. What number can I use as a base and take it to some power and end up with 8 and 16? That number is 2. That's what you got to figure out when you're looking at these problems. Once you get it written like this, it's pretty straightforward. I would say this is the biggest step right here to get it written like this. Now we're going to use our laws of exponents. In this case, we multiply those together. We multiply these together. And you need to think of this as the quantity 3x plus 1 and distribute that 3. That's just a property of exponents. Now that gives us 2 to the 12x equals 2, and distribute the 3 would give us 9x plus 3. And we had to go through all that just to get our equation in this form. A to the x equals a to the y. So our a value is 2. And then our exponent, our x value, is a little weird because we've got x's floating around, but now this exponent is 12x and the other one is 9x plus 3. Now that we have the bases the same, that's my printer, we can set these exponents. Oh, I just crossed that out. Let's try that again. Now that we have the bases the same, we can set these exponents equal to each other. I'm going to write that on the next line. So I have 12x. That printer's got a cycle. Okay, I'll just be quiet while it finishes. So I have 12x equals 9x plus 3. Now, using this rule up here, I've created a linear equation that I can solve. I've created a linear equation that's going to help me solve my exponential equation. Now, all I have to do is get x by itself. So I'm going to minus 9x from both sides. That gives me 3x equals 3. Divide both sides by 3 gives me x equals 1, and that is my answer. Let's go ahead and check that just to be sure. So we could take our original equation, write it over here, and I'm going to plug 1 in where the x was. So 16 to the 3 times 1 equals 8. That's my check. 8 to the 3 times 1 plus 1. So 16 to the 4th equals 8 to the, I'm sorry, 3 times 1 is 3. 16 to the 3rd equals 8 to the 3 times 1 plus 1 would be 4. And you can check that out on your calculator, and I'm pretty confident that that those are going to be the same. Let's go ahead and check it. Here we go. We'll bring in a little calculator here. Okay. View scientific. 16 to the 3rd equals 4,096. 8 to the 4th equals 4,096. Alright, so that worked. Both of these equal 4,096. They came out to be the same. That means my answer is correct. Alright, let me write one up here real quick for you to check, for you to try, and then I'd like you to pause the video and try it yourself, and then unpause the video when you're done and see if you got it right. So here's the one I want you to try. How about 9 to the 3x plus 1 equals 27 to the x minus 2. And give that one a try. Now I'm going to tell you this one doesn't come out nice like the other one. It's going to be a fraction. Pause the video and give it a try. Alright, hopefully you got it right. The answer you should have come up with is x equals negative 8/3 or negative 2 2/3. I hope that worked out for you. If you have any trouble with that, you can either leave a comment or drop me an email and I'll be happy to help you.